Welcome to Module 6 of the IBT 16S course. Just before we get started on the downstream analysis that we're going to be focusing on in this module, I'm going to show you how to implement a Data2-based 16S pre-processing that you've learned in a previous module in a workflow language called Nextflow. So again, we have a module website, and if you have a look there, you'll find some general information. You'll find the syllabus that we're going to cover. So we're going to introduce you to Nextflow. We're going to have a hands-on introduction running Data2 as a Nextflow pipeline, and thereafter we'll move on to the R stuff. At the bottom of this page, you'll also find some useful links that might be applicable to you once you start doing your own data analysis. So keep them in mind and go through them at your own time. So a general overview of what Nextflow is. So it's a scalable, reproducible scientific workflow that uses software containers. It has built-in GitHub support, compatibility with virtually all computational infrastructures, including all major cluster job schedulers like PBS and Slurm, and integrated software dependency management, which is really very useful. So in this module, we're going to be using Singularity containers that have all the software that we'll need, so Data2 and anything else that we'll need in there for fast QC, trimming and filtering, report generation, and so on. So Nextflow is highly portable, so you can run your pipeline anywhere on your own laptop, on the cluster or the cloud, and it's very easy to hop between those different platforms with just a simple config file change. Your analyses are also reproducible. So independent of the time and computing platform, you can be sure that because your software is packaged in a Singularity container, that is recorded, and Nextflow also has excellent error tracking and report generation, which literally tracks every single step in your pipeline, and you can refer back to it at any time point. So at the Computational Biology Lab at UCT, we now actually implement all our high-throughput pipelines in Nextflow. And whether you need to build your own customized pipeline from existing scripts, or you're looking for an existing pipeline that someone may have already written in Nextflow that you can just adapt to your own cluster, I thoroughly recommend investing a bit of time in learning Nextflow, and let me show you why. So it'll save you heaps of time in the long run. You can reuse your existing scripts, as I mentioned, and these can be in any languages, so you don't actually have to relearn a whole new language. You can package your little scripts, whether they're in R, Python, Bash, whatever, into Nextflow processes, and they will be linked together as a workflow in this language. Another very useful feature of Nextflow is that if your pipeline crashes with an error at whatever stage, you don't have to restart the pipeline right from the beginning and wait until you get to that error to try and debug. You can actually resume the pipeline from your last error because all your intermediate results are cached in the pipeline. And they are also tracked with errors, so each and every process has a run script file and an error file, which helps you debug and see exactly what went wrong. And the initial setup for Nextflow is also very easy. You need Java 8 or more installed, which is available on most clusters anyway. You download Nextflow in a one-liner command, and then you're literally ready to get started. Nextflow is very well documented, which is great if you're just starting to learn Nextflow. You can literally find anything you need there, and these links are also available on our website. It also has very good active Google group support where you can post questions if you're stuck, and you will most likely get an answer fairly quickly from one of the users. And there are also quite a few existing pipelines and very good templates. So before you build your own pipeline, it's definitely worth seeing what's available already and whether you can't maybe use one of those pipelines and just adjust it slightly for your needs. So if we look at this NF Core website, it's a collection of very well curated pipelines that need to meet specific requirements to be listed here. And this same organization also has really good templates that I recommend using if you're building your own pipeline from scratch. So here we can see there are various pipelines, chipsec, amplisec. Really, it's getting more and more biological pipelines are implemented in Nextflow. There's a really good RNA-seq one here, so I recommend having a look here if you are looking for a specific pipeline for your own data analysis. Okay, so let's start with the basics of Nextflow. We don't have time to go into a lot of detail on Nextflow scripting, but just the basics is enough to get you started. So in Nextflow, I mentioned the processes, which is basically one step in your pipeline. And this is defined in a Nextflow script, which started off with this line at the top. And then you would define your input parameters, which can be maybe your input FASTQ files or parameters for trimming and filtering that you'd like to use. And then your process starts with a name, which can be anything, maybe filter and trim. And then within this block, there are certain directives. So there's always an input block, an output block, and a script block. So if we look at the terminology, a process is one independent step in the pipeline. And then a channel links processes together. So information will flow from one process to another via these channels, as defined in these input and output sections. And then your script block is where your executable code is. So maybe you have a pipeline in R, then in the script block will be where your actual R code is. And then the executor refers to the system that actually executes and supervises your pipeline. So if you're on the cluster, it takes control of your job submission to various working nodes, and takes note of the resources that you specify for each process, and also records errors for each and every process. And this is something that can easily be modified via a config file. So it's very easy to switch between two different types of clusters, for instance. So here's a more graphical view of what a Nextflow pipeline would look like. This graph is automatically created once you've built your Nextflow pipeline on GitHub, and it shows you the various processes that are in the little bubbles. So filter and trim would be one process. That's where we're going to take our FASTQ reads, filter and trim them. And the arrows are your channels. So your files and your parameters will flow into one channel to this process, and from this process the filter and trimmed reads can actually go to various other processes, and this is all taken into account by the executor once this process is finished, where it can pass the information and what processes can run next. So if we look at a script example, again, we start with this user bin in Nextflow line right at the top, and then we're going to specify our parameters. So in this instance, the goal is to split the FASTA file into multiple files. So the input file is the sample.fasta, and don't worry too much about the details, but basically parameters are specified with a params dot, and then this in you could have called anything. And then we start with our process, which in this instance is called split sequences. We've got our input block, our output block, and this is our scripting section. And this is where the actual code happens to split the FASTA. So this would be what you previously would have had in your script file without Nextflow. And once this process completes, this output block looks for all files that have the seq identifier. So that's a regular expression that it looks for, and then it sends it to the process reverse, which has in its input statement looking for file X from records, and here in the output we call this records. So that is how you would link two processes together in Nextflow. And again, this process has its own output block, which may or may not be redirected to another process, and then it'll print out your result for you. Another very useful feature of Nextflow is automatic generation of Nextflow working reports. And if we have a look at this, it gives you a lot of useful information. First and foremost, was your execution successful? So did each and every process complete successfully without errors? So here we can see 71 tasks succeeded. It would have been highlighted in orange or red if we had errors. It tells you how long the pipeline took, the exact Nextflow command that you use. So this will be, for instance, what we submit on the command line with all the parameters that we need. And it will also tell you exactly where to go look for your error files. So it'll tell you where all your results are stored, and it'll also track resources. So if you're on a cluster environment, it's important to allocate the right amount of CPUs to each process, and often you have to figure that out by trial and error, and that's why these reports are very useful, so you can see exactly what your resource requirements are. And for every process you have some detail here. This will give you the exact working container where Nextflow has automatically saved the results. So that's how it manages to resume a pipeline if it's had an error, because it's cached all the results for each and every step. And we get a variety of resource usage stats here as well. So that was a very brief introduction to Nextflow. If you are interested in learning more, you can have a look at this Nextflow documentation, and I think that's really the best place to start. It has several examples, requirements, installation, building your first script, how to build containers, and so on. In the next session, we'll have a hands-on try at executing our Data 2 pipeline in Nextflow.